Make sure before you completely start this lesson that you've read through all of the vocabulary terms. This section is over matrices. Matrices would be the plural. This is a matrix. A matrix. Each one of these is a matrix. All of them are matrices. The numbers within a matrix are the elements. Horizontally are the rows. Vertically are the columns. So this matrix that you see is a 3 by 2 because there are 3 rows, 2 columns. Beneath it is a 2 by 3. 2 rows, 3 columns. This is a square matrix because it has 2 rows and 2 columns. You are asked to find what is called the determinant of the matrix. A determinant simply means that it is a single value that is used to represent a square matrix. On a 2 by 2 matrix, calculating the determinant is pretty simple. You multiply these values, you multiply those values. So 5 times -4, 2 times -8, and you subtract. Now remember, minus a negative is the same as plus a positive, so the determinant for this matrix is -4. Okay, so on this problem, we've got a 3 by 3 matrix and we're looking to calculate the determinant. The reason I know that it's a determinant is because it's got vertical lines here rather than the brackets that would just denote it as a matrix. I would not recommend doing this by hand. It's a pretty detailed process. Instead, we will do this on our calculator. So you will go to second and the x to the -1 button, and that will bring up the matrix menu. Arrow over to edit, and we'll edit matrix A, so hit enter. Now you want this to be a 3 by 3 matrix, so I just hit 3 enter, 3 enter, and then I filled in the values. Once I'm done with this, and I hope that you've noticed everything travels horizontally, I quit out of this screen and have to go back into it. And now you can see matrix A is a 3 by 3 matrix. Arrow over to math. Determinant is the first option, so you hit enter. Back into it, select matrix A, and enter. And the determinant of matrix A is -36. What you can see in this next problem is that we actually have a system of linear equations, and we're going to use what's called Cramer's rule to solve this. Cramer's rule is a way to use determinants to solve a linear system. So the first thing that we need to do is we need to calculate the determinant of the matrix with the coefficients. So 4, 3, 1, -2. After we do that, we need to find what's called d sub x. And d sub x means you take this original determinant, but in place of the x coefficients, you're going to put your constants. So that's 2, 3, 5, -2. And then you will find d sub y. Same idea. You're going to start with this one, but you'll replace these y coefficients with your constants. So we can put all of these into our calculator and come up with each determinant. Pause the video and do that now. It's very important to calculate this determinant first because if it's 0, this process won't work. But what we find is that this one is -11. I then find that d sub x is equal to -19 and d sub y is equal to 18. The way we're going to use this to calculate x and y coordinates is that the x coordinate is equal to d sub x over d, and the y coordinate is equal to d sub y over d. That's why, if your determinant is 0, this doesn't work because you have 0 in your denominators. So d sub x over d ends up being 19/11ths, and d sub y over d ends up being negative 18/11ths. So your solution now we have a problem that we haven't seen before. We've got 3 equations and 3 variables. The first thing that you need to pay attention to is the fact that all of your constants are on the left of the equal sign. You need to move them over before you do anything else. So I'll rewrite the system. So on a problem like this, we are still going to calculate the determinant d. We will calculate d sub x, and again we will replace the column of x coordinates with our column of constants. We will calculate d sub y, and we will replace our y coordinates here with our constants. And we will calculate d sub z. And hopefully you could predict that we're going to replace this column of z coordinates with the constants. I also want to make sure that I point out this is negative 4, not just 4. Anything that doesn't have a coefficient in front of it is 1. This one here is negative 1. So when we are looking for the x value, we'll take d sub x over d. When we find the y value, that will be d sub y over d. And then the z value will be d sub z over d. And I will let you calculate those.